Hello everyone, I am Jagdish Patel, Assistant Professor, Sandeep Foundation, Nasik. The name of subject is Broadband Communication System. This is Unit 5th, Satellite Subsystem. Lecture number 1, Introduction to Satellite Subsystem. I am having 12 years of teaching experience, specialization in digital communication. Satellite Subsystems. Major satellite subsystems are altitude or orbit control system. Maintains and stabilize satellite in the orbit. Telemetry, tracking, command, and monitoring TTC and M. Take and process measurement on satellite health and position. Power subsystem generate and distribute power to various components of satellite. Communication subsystem receives, process and retransmit the signal. Satellite antenna receives and transmit EM waves. Superstructure construction of the satellite that is used as a mount for all other components. Thermal subsystems maintains the temperature of the satellite within a prescribed range. Satellites have life expectancy of 10 to 15 years. Many components are developed in redundant configuration to minimize probability of satellite failure. If you observe here on the right hand side, all the components or subsystems are located on the satellite so that from this we will come to know their purpose and their applications. If you observe in a gray color, used for command and data. Here yellow color is used for pointing control. Green color is used for communication, that is transmitter and receiver, high gain antennas. Red color are used for to supply the power, that is power supply. After that, navy blue color used for mission payload, and this golden color used for thermal control. So these are the major components of Lockheed Martin remote sensing satellite. Here everything is placed together so that satellite can function properly without any disturbances. Next is altitude and orbit control. Two principal tasks: stabilize the orientation of satellite, maintain the position of satellite in orbit. Four ways of stabilization: spinning, momentum wheels, reaction wheels, control movement gyro. Orbit is maintained using control thruster. The amount of fuel available for thruster operating in the fundamental limit on the satellite lifespan. Different methods of satellite stabilization. Here there are four methods, as we have seen: spinning, momentum wheeling, reaction wheels, and control movement gyro. And here if you observe, this one is Boeing 376 spacecraft configuration. Here there are the different parts: the reflection antenna, after that antenna fed, thermal radiator, control thruster, apogee kick motor, solar cell array, battery pack, traveling wave tubes amplifier, dispense repeater shelf. Boeing 376 is one of the most popular geo communication satellite. Operates in CKU bands, usually 24 transponders, 50 satellites over 5 continents, used by more than 20 companies. Telemetry, tracking, command and monitoring. TTC and M. Distributed between the satellites and the Earth station. Satellite provides measurement, position sensing, environmental sensing, and alarm. Satellite may have few hundreds of different sensors. Major data sends over TTC and M link to the Earth station. The TTC and M link is the narrow band link, allow for high sensitivity reception. At the Earth station, major data process and commands are issued to the satellite. TTC and M may be operated by satellite owner or it may be outsourced. TTC and M systems are built with redundancy. If you observe here the block diagram of TTC and M system, that is telemetry, tracking, command and monitoring. So satellite is communicating with the help of transmitting and receiving antenna to the telemetry receiver tracking system. After that, the data is given to the data processor and computer for attitude and orbiter control. After that, the controller signal is given to the tele command transmitter. Transmitter transmit the signal with the help of transmitting antenna to the satellite. In this way, the communication between satellite and the Earth station takes place with the help of these parameters. Power systems used for generation and distribution of power throughout a satellite. Three types of power system. Solar, the most frequently used in commercial satellite. Chemical, used for backup to power satellite during solar eclipse. Nuclear, used for satellite leaving the Earth orbit, deeper space exploration. Source of power generation is solar panel. Solar panel consists of many string solar cell connected in parallel. Solar energy in Earth orbit has density of 1390 watt per meter square. Three axis stabilized satellite use flat solar panel. Spinning satellites have solar panel on the cylindrical surface of the satellite. Efficiency of solar cell is about 20%, that is only 20% of the sunlight might be converted to energy. The energy is used to charge satellite batteries and to power rest of the satellite. The power needed for the satellite may be in the range of 0.5 to 10 kilowatt. Majority of power is consumed by the communication equipment, that is RF amplifier on the transponder. And here this one is a block diagram of solar power generation system. All the parameters which we have been listed are placed in the block diagram, which are used for different operations. Communication satellite, most important, that is revenue generating part of the satellite. Satellite repeaters in the sky. Band for satellite operation is L, 2 gigahertz to 1 gigahertz, S, 4 gigahertz to 2 gigahertz, C, 6 gigahertz to 4 gigahertz, X, 7 to 8 gigahertz, KU, 12 to 18 gigahertz, and KA, 27 to 40 gigahertz. Early communication satellite power limited used narrow band transmission. Complementary satellite bandwidth limited use wideband transmission and frequency use. Frequency allocation handles through ITU on the global basis. Management of the satellite in the US are conducted by Federal Communication Committee FCC. The unit of satellite communication capacity and transponder. Here this one is outline of satellite communication system. Here the satellite is receiving the signal from the antennas, that is uplink signal, and it is transmitting the signal from the transmitting antenna, that is downlink signal, and the signal will be received by receiving earth station and the signal will be transmitted with the help of transmitting earth station. The receiving earth station is having number of different blocks through which the signal is passing, that is no noise amplifier, down converter, demodulator, decoder, and then the output is transmitted. And in the transmitting earth station there are again different blocks through which the signal is processed and transmitted to the satellite, such as input information is coming can be encoded, provided to modulator to modulate the signal, up converter used to convert or used to increase the power level of the signal, and high power amplifier used for amplification before transmission to the satellite. Satellite transponder. Two types of satellites. Bent pipes, that is transparent and regenerative baseband processing. Smallest accessible recourses. Satellite transponder. Satellite usually host many transponder. Some of the transponder may be spare. Typically, active transformer count is 24. Satellite usually operates in single band, although there are some multi-band satellites. Bandwidth of satellite transponder is a compromise between power efficiency and the limitation on linearity of power amplifier. Most common bandwidth of the transformer is 36 MHz. Some satellites adopt 54 MHz or even 72 MHz. Basic of band points architecture is shown, and below that there is satellites onboard processing. The signal is given to the satellite with the help of uplink antenna, and signal is transmitted from the satellite with the help of downlink antenna. Transponder arrangement, fixed frequency translation. So this one is the arrangement of transponder. Example of transponder arrangement for RCA SATCOM. Basic design, each transponder is individually chained with fixed frequency translation. Bank of transponder are arranged to achieve higher frequency separation, that is 80 MHz. Minimize intermodulation product. Simplified signal conversion transponder. Here the receiving antenna receives the signal passing through LNA. Band pass filter. Signal is mixing of the signal is done. After that it is again given to the band pass filter. After that power amplifier and transmitting antenna, and the signal is transmitted. And these are the equations which are used to do the calculations for the received signal in the mixing stage. So here we have seen different subsystems of the satellites and different components for which they can be used. Thank you.